Okay, so now let us look at these two problems. Let's look at the first one. If we have E1 is 1, 0, E2 is 0, 1, those are, you know, the standard basis, right, for R2. And Y1 is 2, 5, Y2 is negative 1, 6. Let T from R2 to R2 be a linear transformation that maps E1 to Y1, maps E2 to Y2. Figure out what is the image for 5, negative 3, and X1 and X2. So, so first of all, T is a linear transformation, okay? We are actually looking for, what is T of 5, negative 3, okay? And then what is T of X1 and X2? What we already know here is T of E1 equals Y1. T of E2 equals Y2. Okay. So the thing is, this vector 5, negative 3 actually can be represented as 5 E1 minus 3 E2, right? Because the property about a linear transformation, so T of this vector equals T of this. And because, again, T is a linear transformation, based on its property, it's going to become into 5 T of E1 minus 3 T of E2, right? So do you agree that we already know what TE1 is, which is Y1? TE2 is Y2, so it's going to become into 5 Y1 minus 3 Y2. So that is super easy. So it's 5 times 2, 5 minus 3 times negative 1, 6. So it's going to become 10 plus 3, 25 minus 18. So it turns out it gives us this is 13 and this is 7, right? So that's how do we drive this. Cool. Once you got the idea about this pieces, so do you realize that it's exactly the same logic? How do we construct x1, x2? So x1, x2 can be rewrite as x1 e1 plus x2 e2. So T of it. And again, x1 and x2, those are scalars. So it becomes into x1 T of e1 plus x2 T of e2. So we know that this is y1, this is y2. So this is x1 times 2, 5 plus x2 times negative 1, 6. It becomes into 2x1 minus x2, 5x1 plus 6x2. Yeah, so that's it. That's going to be the image of this. All right, simple. Number 5, if we have this matrix, figure out what is the inverse of this given matrix first. And then second, figure out what is inverse of its transpose. Second one is easy because the inverse of its transpose equals the transpose of its inverse. In other words, if we got part A correctly, we just do the transpose. Simple, right? Rows becomes columns. So how do we figure out the inverse of this matrix? Well, the traditional way here is you put the identity matrix as the augmenting part, and then starting from here, you're trying to do the row reduction. If you can make the left-hand side to become the identity matrix, then whatever you get on the right-hand side is going to be the inverse of the given matrix here, okay? So that's how do we do this pieces here. Okay, so let's do that. I can use row 2 minus row 1 becomes new row 2, right? I can use row 3 minus row 1 as new row 3. So this becomes into 1, 1, 1, 1, 0, 0. So row 2 minus row 1. So it's a 0, 1. This is negative 1. This is negative 1, right? This is 1. This is 0. Row 3 minus row 1. So this is 0. Negative 1. 0. And let's see. We can. So this is negative 1. This is 0. This is 1. Okay. And then what you can do here is, you can make this part to be 0. So that is R3 plus R2, right? To become the new R3, right? And then you can also do R1 minus R2 becomes the new R1. Okay, so maybe we can do this one first. So it's going to become 1, 0, right? This part becomes into, so R1 minus R2. So this is 2. This is 2. This is negative 1. This is 0. So R2 nothing changed. 0, 1, negative 1, negative 1, 1, 0. And use R3 plus R2 becomes new R3. So 0, 0. So this is negative 1. And then, so negative 2. 1. 1. Okay. This is what we have here. So it's almost there. We can use R1 minus 2, plus 2 R3 becomes the new R1, and then use R2 minus R3 becomes the new R2. So it's a 1, 0, 0. I just do. This is going to be negative 2, right? Plus R3, 2 R3, so it's a 1 on 2. R2 not, R2 minus R3, so it's a 0, 1, 0. Excuse me, this minus this part becomes a plus. This is 0, this is negative 1. And the R3, it is 0, 0, negative 1, negative 2, 1, 1. And very quickly, if you, excuse me, times negative 1 R3, right? So R3 times negative 1 becomes new R3. So it's 1, 0, 0, negative 2, 1, 2, 0, 1, 0, 1, 0, negative 1, 0, 0, 1, 2, negative 1, negative 1, and then, oops, what I'm doing. That's it. Okay, so this is going to be its A inverse, okay, from part A. And then once you got this part, and then the part B, we know that the inverse of the transpose equals the transpose as the inverse. So it's going to be negative 2, 1, 2, 1, 0, negative 1, 2, negative 1, negative 1. Okay, so that is the inverse of this transpose. Okay, so we're done with this. All right. Thank you for the watching.